We plug our phones into everything. Airport kiosks, hotel lamps, printers, rental cars, conference booths, airplane USB ports, strangers' laptops, smart desks. USB charging has become completely normalized, and sometimes we don't realize that what we're plugging into is actually another computer.
Some hackers have compromised some of these USB ports and are getting everything that's on your phone, your bank information, your contact list.
USB connections are often doing two jobs at once, delivering power and opening a channel for data. And if you don't control what you're plugging into, that data connection might be used to steal information or load malware onto your device. One thing that can help is this. It's called a USB data blocker, and it's a cheap piece of hardware that is criminally overlooked. In this video, I'll talk about why you shouldn't plug your phone into random USB ports, and I'll explain how USB data blockers help and how they work. Let's start by understanding the dangers of plugging your device into unknown USB ports. First, there's juice jacking from malicious USB ports.
Here's how it works. A scammer puts malware or monitoring software into a public USB port. That gives them the ability to steal data, passwords, addresses, banking information of a phone when it plugs in.
Then there's the risk that the cable itself might be malicious. We've talked about things like the OMG cable on the show before.
It looks and feels just like one that you may have, but it's malicious.
While to the eye, it's indistinguishable from a normal cable, the big difference, of course, is that this one
Has a computer inside of it with a Wi-Fi access point that you can control from your phone or anywhere in the world and do malicious things with the computer that it's attached to. You can connect to them from your phone or laptop. You can use that to trigger payloads.
So you should never plug in any charging cable that you just find lying around. And finally, there's the privacy side of plugging your phone into things. What you're plugging into might not be malicious, but you could be unintentionally sharing data without realizing. Cars are a great example of this. People often assume that their own car is private and neutral, and that any USB connection there is safe because it's their vehicle. But cars are packed with connected services and third-party integrations. When you connect your phone to your car,
the car essentially downloads a mini clone of your phone.
You shouldn't be plugging into public USBs anywhere in the world, period.
Okay, well, my car isn't a public USB. It's my personal car. Does it really matter if I share this information with my car? Yes, because remember, this data isn't staying with your car. It's shared with countless entities.
There's an entire explosion of data collection in cars.
The worst part of it is that we have no idea who will get access to this data. Car companies, ad companies, hackers through data breaches, and of course,
Massive data brokers that collect data from all sorts of manufacturers and they sell it.
sometimes you might just want to charge your phone in your car without sharing your phone data with countless third parties. Now, how likely is it to fall victim to one of these dangers mentioned? A malicious USB port doesn't usually get instant access just because you plugged in. A few things are required, and there are some protections built into your phone. First, Android has something called USB protection, which can block USB data while locked. And by default, iPhones and iPads enter a protective state called USB restricted mode. If the device has been locked for more than an hour, it won't communicate with an accessory or computer until you unlock it, though it will still charge normally from a USB power adapter. But you don't always keep your phone locked when it's charging, so these charge-only modes won't necessarily protect you. Next, on Android and Graphene OS, you can change your security settings so that you only ever allow charging through the USB port and not data. But this setting will have to be shifted back if you ever want to connect the device to your computer or speaker, etc. Then there are trust prompt protections. For example, often, to enable data transfer, you have to approve some kind of pop-up. Some of these might auto-appear in a way that's easy to tap accidentally, or approve when you are half awake in an airport, for example. But sometimes consent gets bypassed. There are cases where your phone might automatically say yes without you even having to tap anything. For example, if you've previously trusted that computer, your phone might remember and not ask again. so a malicious device can potentially impersonate a trusted device. Finally, if your phone is running outdated software, the chances of being successfully attacked by a malicious USB port goes up significantly. These risks end up being non-trivial, but luckily, there is an easy way to protect against all of them at the hardware level before the phone even has a chance to negotiate a data connection. You just need one of these, a USB data blocker. So what exactly is a USB data blocker? It has many names, like a charge-only adapter, or a juice jack defender, or more risque names like a USB condom. It's a small adapter that sits between your device and whatever you're plugging it into. If you want to charge your device, you could plug the blocker directly into your device and then plug your charging cable into the blocker. What is the point of this? Using a USB blocker blocks the flow of any data and allows only electrical power through. So how does a USB blocker work? It's all done through the physical pins inside the USB port itself. Let's start with a USB-A, which is the square-shaped USB that always seems to go in the wrong way the first two tries. If you cut open a USB-A cable and peel back the outer plastic jacket, you'll find that it isn't just one solid wire inside. It's actually 4 thin wires bundled together, each wrapped in its own colored insulation. Each of these 4 wires has a specific job, and they fall into 2 categories. 2 of them carry electricity and 2 of them carry data. This wire is called voltage positive, and this wire is called ground. Electricity needs a complete loop to flow, so the V positive wire delivers the electricity and the ground wire gives that electricity a path to return. And together, these 2 wires make charging possible. The other 2 wires are data wires, D+ and D-. These don't carry power. They carry information. When your phone sends a photo to your computer through a USB-A cable, that photo is actually being chopped up into millions of tiny electrical pulses, and those pulses travel along the D+ and D- wires from the phone to the computer. And if you look inside a USB-A port, you'll see 4 metal pins, 1 for each of the 4 wires inside the cable. If you look inside a USB-A data blocker, you'll see only 2 pins, because it's physically severing the connection of the 2 data pins while keeping the power pins intact. This means that electricity flows freely, but no data flows. Now, this is just for USB-A. USB-C cables are much more complex internally. They have many more wires inside the cable and 24 pins in the connector to support things like faster charging, video output, and reversible plug orientation. But the basic principle of separating power pathways from data pathways still applies. Unfortunately, you can't visually verify what's being cut off with a USB-C data blocker because the internal wiring isn't inspectable by eye, and the pin count makes it non-obvious what's connected to what. So with USB-C, you largely have to trust the manufacturer's claims. This is a good reason to buy USB-C blockers from reputable brands with clear technical documentation rather than no-name products. It's also worth noting that cheaper USB-C data blockers may not support fast charging protocols and may limit you to standard 5-volt charging speeds. Now remember, you'll only want to use a data blocker when you just want to charge your device. Using one means giving up legitimate USB functions like photo transfers, Android Auto, tethering, etc. A blocker will interfere with all of that data communication. But that's the point. And when you just want to charge, a blocker gives you a simple assurance that only power is crossing the connection. For a fully updated, locked phone, plugging into a malicious USB port is fairly low risk. You'd likely need to actively grant trust, or the attacker would need a real vulnerability. And compared to threats like phishing, it's less to worry about. But why worry at all? Relying on being perfectly patched and attentive at all times is a bad strategy, especially when you can instead just block the data path and move on. and especially when it costs less than a cup of coffee and does the job so well. This video was brought to you by the Ludlow Institute, a non-profit dedicated to advancing freedom through technology. We are supported entirely by community support. If you would like to support this work and keep this channel free and accessible to more and more people, visit ludlowinstitute.org/donate. I really appreciate every single one of you who supports this channel. It means so much. Also, have you checked out our store recently where we have some really cool t-shirt designs? Go and do that.